All right, so this is 7.1 in Algebra 1. We are applying exponent properties involving products in this section. So we're going to introduce exponents in this chapter and how to apply the properties that come with them. So follow along with some of these properties, and then we're going to try and apply these. So what we're looking at here is we're going to use the product properties of exponents to simplify exponents. Okay, so we've learned that multiplying is a quick way to add. In a similar sense, using exponents is a quick way to multiply. So basically what we're looking at here is, if you notice a squared, so one of the things that you hopefully know about exponents is that an exponent represents how many times you're multiplying something by itself. So a squared is the same thing as a times a. A to the third is the same thing as a times a times a. So the exponent just represents how many times you're going to multiply something by itself. Well, if you notice, if we're multiplying this all together, we have 2 a's here, we have 3 a's here, which gives us a total of 5 a's. So the property that we're going to deal with here is when we are multiplying two bases like this that are the same, we can just simply add our exponents. So it'll be 2 plus 3, which is 5. So our property here is a to the m times a to the n is just going to be a to the m plus n. All we're going to do is add these exponents. Now, the one thing you have to be aware of, the a or the base, we call the base is, say if I put x and then I say to the third power, x is considered your base, 3 is your exponent. If it's 3 to the 5th power, 3 is your base, 5 is your exponent. So when we use those words, you just need to be able to follow what we're saying when we say that. So let's look at a few examples here, and then you're going to try some on your own after we go through these examples and a couple of the properties. So the bases are the same. We have 4 and 4, and we have exponents of 7 and 6. So what this looks like is 4 to the 7 plus 6. So all you have to do is add 7 and 6, and you get 4 to the 13th. So on problems like this, we're not looking for you to actually just plug this into the calculator and give a really large answer. We want you to just simplify what this would look like, 4 to the 13th power. Over here, we have negative 3 to the 3rd power, and we have negative 3. The one thing that we want to pay attention to here is there's no exponent here, but that doesn't mean it's 0. It means that it's 1. So you have to be very careful when there's no exponent. The exponent is just 1. So this will be negative 3 to the 3 plus 1, which equals negative 3 to the 4th power. And if you were to keep going from there and give a number from there, that'd be okay. But again, we're just here trying to simplify exponents and understand these properties. Next one, we have b to the 3rd, b to the 5th, b to the 2nd. Again, recall that this will be 1. So this will end up being b to the 1 plus 3 plus 5 plus 2. So you add those all up, and you get 11. So we have b to the 11th power. And then this last one, again, we go through the same thing. It doesn't matter whether it's a letter or a number. As long as the bases are the same, it's going to be the same concept. So this will be 8 to the 5 plus 1 plus 2. So we have 8 to the 8th power. Okay? So hopefully that makes sense. The one thing that you want to pay attention to is make sure you understand the concept of why we add. You don't want to memorize this formula here. It's not about memorization. It's about understanding this part up here. If I have a squared, then I have 2 a's. If I have a to the 3rd, then I have 3 a's. That will always help you remember that you're supposed to add, because just think about how many you have total, and that should help you figure out what your operation is instead of you trying to memorize it. That's the number one most important thing about these rules, is not trying to memorize them, trying to understand logically why they work. Okay, so the next one, and again, pay attention to these. These are the parts that explain why it works the way it is. So this is a little bit different. It says a to the 2nd, and then on the outside we have a to the 3rd. So look at how we write that. That means that whatever's on the inside of here, we're going to do that 3 times. So just like if we had x to the 3rd, it would be, x to the 3rd is equal to x times x times x. This is the same thing. This is just a squared 3 times. So a squared times a squared times a squared. And you could use our old property to do this, where we're just adding 2 plus 2 plus 2 is 6. Or you could separate them into a times a times a times a, and you still have 6 of them. Or what's easier is because we have a squared 3 times. Notice that word I just said, 3 times. So a squared 3 times, we're just going to do a, and then we're multiplying the 2. So a power to a power is just simply multiplication. A to the m n times will be a to the m times n. Okay, so let's look at these examples down here. All right, so we have 7 to the 4th to the 5th power. So that's a multiplication problem, but basically what you're looking at is, I'll write it out once here. This is 7 to the 4th 5 times. Okay, so when you write that out, that would be 4 plus 4 plus 4 plus 4 plus 4. But adding 4 5 times is the same thing as just multiplying 4 times 5. So that's 7 to the 4 times 5, which is just 7 to the 20th. Okay, our next one, we have negative 3 to the 4th to the 2nd. And again, I'm not going to write this all out again. I'm going to use the property now because I know it's negative 3 to the 4th 2 times. So it's just going to be negative 3 to the 4 times 2, which gives us negative 3 to the 8. Next one, we have y to the 3rd 3 times, so it's y to the 3rd times 3. So you get y to the 9th. And then this last one is a little bit more difficult, but again, it's n plus 8 to the 2nd power. Don't worry about anything in that parentheses right now, because all we're looking at is these two powers. It's n plus 8 to the 2nd power. So we would be writing n plus 8 to the 2nd power 9 times. So don't let any of this extra stuff confuse you. It's still the same thing. It's n plus 8, and then it's 2 times 9. So it's just n plus 8. 2 times 9 is 18, so it's n plus 8 to the 18th power. So that's the second property. And those are the two main properties that we're dealing with in this section. Okay, we have, you need to know the difference between these two. One, we're just simply adding our exponents. That's where we have the same base that we're multiplying. Again, a squared times a to the 3rd is 5 total a's. That's adding. But when we have a power to a power, we're writing whatever we have inside that parentheses, the number of times on the outside, which makes it a multiplication problem. So it is important for you to know the difference between these two properties and making sure that you don't confuse them and multiply in one and add in the other when you're supposed to be doing adding in one and multiplying in the other. Okay, so let's move on to the back side of the notes. What I want you to do is I want you to go ahead and do these ones on your own. And you're going to hit play on, hit pause on the video. So hit pause on the video, take a couple of minutes and do these ones, and then go ahead and hit play when you're ready, and you'll see the solutions to see if you're doing them right. This is all to see if you can do these on your own. So go ahead and hit play when you're ready. All right, so in this first one, hopefully you got 3 to the 9th. You added 2 plus 7, got 3 to the 9th. Next one, added 2 plus 6 plus 1, you get x to the 9th. This one we're multiplying, it's a power to a power, so it's 4 to the 14th. And this last one, another power to a power, it's 3 times 6, n to the 18th. So hopefully those were pretty easy. That's the basic part of this section. So let's move on to the next part. So the next part is talking about when we have multiple things inside of a parentheses and then a power on the outside. So again, let's look at this the long way. This right here explains why it works the way it does. So that way you don't have to memorize. If you can just think logically about how this would work, then there's no need to memorize the rule or anything like that. So you can just, you'll look at it and you'll know. So a times b to the 3rd power is the same thing as taking a times b and multiplying it by itself 3 times. Well, then what you can do is you can separate it into 3 a's. A times a, which is a to the 3rd, and b times b, which is b to the 3rd. So basically what this rule is showing us is that whatever powers on the outside will apply to both or every term on the inside. So this is a to the m and b to the m. If it's a number, then it's going to be a number to whatever that power is. Okay, and you're going to see that in these examples that we do right now. So here we have 34 times 9 to the 6th power. Now, for the purposes here, I don't want you to multiply 34 times 9. All we're doing is using the power of a product. So we're applying the exponent 6 to each one of these. So this will be 34 to the 6th power times 9 to the 6th power, and that's it. You don't need to do anything more than that. That's going to be a really large number. You don't have to do more than that. So next one. We're just going to apply the 3rd power to everything. So it's going to look like this. 4 to the 3rd power times m to the 3rd power times n squared to the 3rd power. So then we need to simplify. So this one we can simplify. 4 to the 3rd power is 64. M to the 3rd power, that's as simplified as it can get. And this one right here, this is the property we just did. So that will be n to the 2 times 3, which will just be n to the 6th. Okay, so again, just do each separate thing to the power on the outside. Okay, here, let's leave this negative for the end. So I'll just leave the negative on the outside. This will be 5 to the 2nd power and x to the 2nd power. This negative will just end up being multiplied, so this will be negative 25 x to the 2nd power. That one should be pretty easy. Okay, this one's a little bit different. Again, watch what I do. Everything is to the 3rd power. So negative 2 to the 3rd power and g to the 3rd power. So you figure out what negative 2 to the 3rd power is, and that's negative 8, and then g to the 3rd power. The number one mistake that students make on these is they forget to apply the power on the outside to everything on the inside. So if it's on the outside of a parentheses, just remember it needs to be applied to everything. Okay, let's look at this next example. It says the order of magnitude of a quantity can be defined as the power of 10 to the x nearest to the quantity. Order of magnitude can be used to estimate or perform rough calculations. For instance, there are about 91,000 species of insects in the United States. The power of 10 closest to 91,000 is 10 to the 5th. So basically what you're looking at here is we have all numbers of 10 to a power will always give us 1 and then zeros. So all they're doing is they're just coming to the closest number. So 10 to the 5th is 100,000, so that's what the order of magnitude is. Okay, so then you just estimate there's about 10 to the 5th species of insects in the United States. Really not a huge deal here, but just to give you a different definition moving forward. So here we have, it says a box of staples contains 10 to the 4th staples. Okay, so that means one box has 10 to the 4th staples. It says how many staples do 10 to the 2nd boxes contain? Well, this is a multiplication problem, because if we have 10 to the 2 power boxes, we would multiply that by the number of staples in each box to get us the total number. So you would just do 10 to the 2nd times 10 to the 4th. And then we use our properties. This is 2 10s, 4 10s, so we add those together. 2 plus 4 equals 10 to the 6th. Okay? So again, you have 3 checkpoints down here. Do those. Hit pause on the video and then hit play when you're ready so you can see if you're doing these right. Really important that you try these on your own to make sure you're doing them right. It's self-assessment. And then just go ahead, like I said, hit play when you're ready, and then we're done. All right, so this first checkpoint should have been pretty easy. Apply the 2 to both numbers. So we have 42 to the 2nd and 12 to the 2nd. That's pretty straightforward. The second one, again, make sure both things are applied to the 2nd power. This is negative 3 to the 2nd power, n to the 2nd power. So negative 3 squared is 9, n squared is n squared. Last one, apply everything to the 4th power, 2 to the 4th, m to the 3rd to the 4th, and n to the 4th. 2 to the 4th is 16. I showed you how we got m to the 12th here. So m to the 3 times 4 is m to the 12th. And then we have n to the 4th. Okay, so this is it for the section. Don't forget to take your Edmodo quiz if that's been assigned, and bring questions tomorrow, and I will see you then.